math is so boring.
Got a damn F.
I think I'm gonna die. I am definitely cooked. I don't freaking understand
I'm
exponents.
definitely failing math.
My
This
math
with math
teacher
is
said
so
I
I'm
got
gonna
an
die.
F.
Stop!
Hey man, wanna go play some soccer?
I have so much fun solving math. Why do people hate math?
Maybe because they haven't been taught the same way as you.
Yeah, I guess you're right.
But you can help them understand how it feels.
Yeah, you're right. I'm gonna make the greatest video on exponents ever.
Now that's what I'm talking about, boy.
You don't need to memorize 200 rules like some human calculators just to solve exponents. All you need are 3 terms. This is the full guide to exponents. First, what the funk is even an exponent? You see, 2 times 2 is 4, right? What if I told you 2 times 2 times 2 times 2 times 2 times 2 times 2?
An eternity later.
You get the point. It's stressful to write or even to say it, and we don't like stress, do we? So this guy, Descartes, if I say his name right, got tired of it and said,
"Fuck this shit, I'm out."
And he created exponents.
Get out of the way, boy. We've traveled back in time to kill him for making this horrendous math.
I know you guys want to hate him, but he actually saved you time.
How?
Let me explain. If you multiply the same number many times, you just write a small number on top. That number you've written on top tells you how many times you multiplied that value. That's called an exponent or power. Why the value being multiplied is the base. So in this case, we say 2 is raised to the power of. That's it. No more writing essays just to do math. The rules, well, not quite. I know I call them rules, but they're more of guidelines so that you don't fall into traps. And they are certainly easy to remember than your crush's phone number. Let's go. Hey you! Yeah, solve 2 to the power of 3 times 2 to the power of 2.
Okay, everything here is 2 times 2 times 2 times 2 times 2. And if I check with my calculator, that is 32.
Okay. Yeah, that's correct. But we don't want to expand every time. So here's the rule. Add the exponents with the same base. Therefore, 2 to the power of 3 times 2 to the power of 2 becomes 2 to the power of 3 plus 2, which is 2 to the power of 5. Simple. Quotient rule. When dividing exponents with the same base, you simply subtract. This is the opposite of what we did in product rule. That's it. For example, x to the power of 4 divided by x to the power of 3, you subtract it, so it becomes x to the power of 4 minus 3, which is x to the power of 1, which is just x. That's it. The power rule. If an exponent is raised to another exponent, you simply multiply the exponents. So for example, 2 to the power of 3 raised to the power of 3 again. This becomes 2 to the power of 3 times 3. So you multiply with the exponent and it becomes 2 to the power of 9. Now, there's a common mistake that many people make, but you won't make that mistake because I'm telling you right now. If there are multiple values or terms in the brackets, don't just multiply only one. Apply the exponents to everything inside so that you aren't caught lacking. I'll show you this in an example later on. Next up, zero rule. Simply, any number or value raised to the power of 0 becomes 1. Whether it's 2 or 1 or a billion or your mama. But why? Well, let's use an example. 4 divided by 4 equals 1. At the same time, 4 is equal to 2 to the power of 2, right? Or 2 squared. This means that 4 divided by 4 can be written as 2 to the power of 2 divided by 2 to the power of 2. Using the quotient rule, that is 2 to the power of 2 minus 2, which is 2 to the power of 0. So now think about it. If 4 divided by 4 is 1, it means that since 2 to the power of 0 is equal to 4 divided by 4, it means that 2 to the power of 0 is also equal to 1. And this applies to every single number. Finally, negative exponents. It's best to explain this with an example. What if we have h to the power of 3 divided by h to the power of 5? If we expand it, we're left with 1 over h squared. At the same time, let's use the quotient rule. H to the power of 3 divided by h to the power of 5 is h to the power of 3 minus 5, which is h to the power of minus 2. So that means that h to the power of minus 2 is equal to 1 over h squared. Do you see the pattern?
Nope.
Simple explanation. If the exponent is negative, flip it and make it positive. A practical example, 2 to the power of minus 2. Now remember, 2 is the same thing as 2 over 1, right? So if we flip 2 over 1, what do we have? 1 over 2, and then because we flipped it, the exponent becomes positive. So that becomes 1 over 2 to the power of 2. What if it's 3 over 2 to the power of minus 4? Flip it, which becomes 2 over 3, and change the minus 4 to a 4. That's done. Now, you know all the main rules, right? Easy peasy, right? You may think. But whoever is making those hard test questions knows that you know these rules. But can you combine them? I have just one question. And trust me, by the time you solve this one question together, you'll be able to do just that. Let's go. Alright, this is the final boss. It uses everything we just learned. Don't panic. Step 1. Apply the power rule. We have to get rid of the brackets. So we use the power rule to apply the exponent to everything inside. Like I said, don't make the common mistake of just applying it to 1. It applies to every single term. On the left part, 3q becomes 27, x squared becomes x to the power of 6, and y to the power of minus 1 becomes y to the power of minus 3. Remember, we're multiplying the exponents. The next part, x to the power of 4 times 2 becomes x to the power of 8, and y to the power of 2 becomes y to the power of 4. On the bottom, 9 squared becomes 81. X to the power of minus 3 becomes x to the power of minus 6, and y becomes y squared. Step 2, multiplication rule. We're going to apply this to the top. Remember that the multiplication rule and the quotient rule only work if they are the same base. So we can group the x together and the y's together and the numbers together too. So x to the power of 6 times x to the power of 8. If we add the exponent, it becomes x to the power of 14. Y to the power of minus 3 times y to the power of 4. If we add the exponent, that is 1. So the top becomes 27x to the power of 14 y. Step 3. We use the quotient rule to divide. Subtract the exponent. Remember, for the quotient rule, 27 divided by 81 becomes 1 over 3. For the x to the power of 14 divided by x to the power of 6. Remember, this becomes x to the power of 14 minus 6, which becomes x to the power of 20. For the y to the power of 1 divided by y to the power of 2 becomes y to the power of minus 1, because 1 minus 2 is minus 1. The next step is negative exponent rule. Y to the power of minus 1 becomes 1 over y. Our final answer becomes x to the power of 20 divided by 3y. That's it. You just use power rule, product rule, quotient rule, negative exponent rule to solve this question. You're officially in the avatar state. The third pillar, which is the most overlooked, is practice. The more you practice, the better and more proficient you'll become. So don't underestimate that. I have a worksheet for you in the link. Just check it out and challenge yourself to those questions. By the time you solve even just 10, you'll already be reaching master level. With these 3 pillars I mentioned, exponents become easy. Not perfect, but easy. And practice makes decent. You get it in no time. Till next time, citizens of YouTube.